9, 10, 11, 12, 13, 14, 15. 15 boys. 3 and 4 is 7, 8, 9, 10, 11, 12, 13, 14. So there are 29 students in the class. Now it says construct a box plot for the entire grade 5. So to construct a box plot, to construct a box plot, we need to know the lowest mass and the highest mass. So I'm writing down. So the minimum is 28. The maximum is 51. Then we need the median. The median is going to be the 15th person's mass. All right, so this is 1, 2, 3, 4, 5. Those are 5 lowest. We need a 15% mass. 6, 7, 8, 9, 10, 11, 12, 13, 14. 15% mass is 39 kg. You might wonder, how did I do that? Well, the 15, it is already in order. 28 is the lowest. So 1, 2, 3, 4, 5. These are the lowest 5. 6 lowest, 7th lowest, 8 lowest, 9th lowest, 10th lowest, 11, 12, 13, 14, 15. So the median is 39. All right. Now the next thing we need is we need a lower quartile, known as Q1. So the lower quartile is going to be, after we identify the 15th mass, which is midway, the 15th mass we saw was, where was it again? So the lowest 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, midway in between 14th is what? The midway between, so for the first 14, we need to go to the 7th and a half lowest to find the lower quartile. 7.5. So these are the lowest 5, lowest 6, lowest 7. So the median is between this now. So it's in between 32 and 33. So the median is 32.5. That's the lower quartile. Then we need the upper quartile. Upper quartile is in the next best 14, which is these two and the rest. So it's going to be 1, 2, 3, 4, 5, 6, 7. So the upper quartile is clearly just 41. So now we can draw our box plot. To draw the box plot, we can start with these. Then we draw the hinge. All right, so we draw the hinge now. As we saw, so the median is 39, the upper quartile being 41. The lower quartile right here is 32.5. And then the highest is highest mass, which is 51. And the lowest mass right here, which is 28. So this is the box plot. Nice and easy. And ask us, it says, the standard deviation of the weights of the boys is 5.53 kilograms, and it says determine the standard deviation of the weights of the girls. Now, to determine the standard deviation of the weights of the girls, and it says provide an interpretation. Now, standard deviation is given by this formula. There are two formulas, but we're going to use this one. Standard deviation is equal to the sum of xi squared minus the sum of xi all square divided by n divided by n minus 1. That's the formula for standard deviation. So I want us to work out what is xi squared. So work out the sum of xi all square here. So that means every term, we're going to square them and add them. Square them and add them. So 28 square plus 28 square plus 28 square plus 29 square plus 29 square plus 32 square plus 32 square plus 33 square plus 35 square plus 38 square plus 38 square plus 39 square plus 39 square plus 39 square plus 37 square plus 33 square plus 32 square plus 32 square plus 33 square plus 35 square plus 38 square plus 38 square plus 38 square plus 51 square plus not 51, 41 square plus 45 square plus 41 square plus 41 square plus 41 square. That's a lot of 41 square. That's 1, 2, 3, 4 of them. 1, 2, 3 plus 41 square plus 40 square plus 40 square plus 40 square plus 41 square plus 41 square plus 42 square plus 51 square. So I get 41,000. This works out to be 41,025. 41,025. Now I need the sum of xi. Now the sum of xi just means you add them up. 29 plus 28 plus 28 plus 28 plus 28 plus 29 plus 39 plus 39 plus 39 plus 37 plus 33 plus 32 plus 32 plus 33 plus 35 plus 38 plus 38 plus 38 plus 45 plus 41 plus 41 plus 41 plus 41 plus 40 plus 40 plus 40 plus 41 plus 41 plus 42 plus 51. I get 1,107. All right. So now what this works out to be is this is going to be equal to, I got 41,000 0.25 minus 1,107 square minus 1,107 square divided by n, which is 29. All of this will then be divided by 28. And so what we're getting is s squared works out to be 1,107 squared divided by 29, then 41,025 minus the answer, and the square root of 44. So I'm getting s squared check that out again, 1107 squared over 29, 44025 minus answer divided by 28. I'm getting x squared is the square root of 63. The square root of 63 is 7.94. 7.94. So what is my interpretation? Hopefully I didn't make any calculation error. And so that interpretation is that the standard deviation of the girls is larger than that of the boys, and so the weight of the girls varies more. It's more widely spread. All right, nice and easy, soft. Out of the 29, when you multiply it by 100, what's going to give you 0.2? This is 20th percentile, 0.2. So let's put this as n. Solving this for n, we're going to get, that is going to be, solving for n, we first divide by 100. So 0.2 divided by 100. Then we multiply it by 29. And so we get and this should have given us the number of students out of 29. I shouldn't put 0.2, let me put 20%. So solving for n from this, I'm getting n is 6. That is 6. N equals 6. So what does that mean? That is 3 students. That means 23 students are above the 20th percentile. So 23 students are above the 20th percentile. That's what that means. All right, 23 students are greater. So apart from the first 1, 2, 3, 4, 5, 6, apart from the first 6 students, the 6 student weight being 32, everybody is above the 20th percentile. Nice. Part B. Part B says a vendor has 15 apples on a tray. 15 apples are on a tray, and it says 5 are red, 6 are green, 4 are yellow. A customer requests 3 apples but does not specify a color. It says, determine the probability that it contains one of each color. So you want to get the probability that the customer get 1 red, 1 green, get 1 red, 1 green, and 1 yellow. So what's that probability going to equal to? So if you get 1 of each color, that means you can either get a red, a green, and a yellow. So that's what you need to get. You need to get a red, a green, and a yellow. All right. So we need the probability of getting a red, a green, and a yellow. Chances of getting 1 of each color should be pretty high. So the chance of getting a red is, let's say you get the red now. Oh, this is not finished yet. All right, let's fix this. All right, so it's equal to the probability of getting a red, a green, and a yellow. Or the order matters. You can either get a green first, then a red, then a yellow, or you can get a green first, then a yellow, then a red, or you can get maybe the red first again, and maybe a yellow next, then the green, or you can get maybe the green first. Or let's start with yellow now. You can get the yellow first, then the red, then the green. Plus, you can get maybe the yellow first, then the green, then the red. All right. This is how you find the probability of getting 1 red, 1 green, 1 yellow. This gives us all the possibilities. All right. So it's just going to work out to be probability of getting a red is, you have 5 red out of 15. That's the chance of getting a red, times the chance of getting a green is 6 out of, now if you take out 1 red, you're left back with 14 times, then now you have yellow, which is 13, all right, and that's 4, all right. Now all of this results, we multiply it by, let me see, 1, 2, 3, 4, 5, 6, so times it by 6. All right, that will give us a probability of getting 1 red, 1 green, 1 yellow. So 5 out of 15 times 6 out of 14 times 4 out of 13 multiplied by 6. That's 24 over 91. This is 24 over 91. That's a chance of getting 1 of each color. So there's a 25% chance you'll get 1 of each color, which makes sense. Really, really makes sense. All right. Nice. Now it says, what's the chances of you getting all the same color? Now, the chances of you getting the same color, the probability of getting the same color, that means you can either get You can either get 3 red, so you want to find the probability of getting red, 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 plus you want to find the probability of getting green, 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 plus you want to find the probability of getting yellow, yellow, yellow. Chances of getting red, 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 well, let's work those out now. So the chances of getting red, red, red would be equal to, first you have 5 red, that's 5 out of 15 first. That would be 5 over 15 multiplied by, now if you get 1 red first on the second draw, it would be 4 red there out of 14. And then if you get another red, then you have 3 red left back, so it would be times 3 out of 13. Nice. Plus, the probability of getting green, green, green would be, first green would be 6 out of 15. Then if you get that green successfully, it's going to then be multiplied by 5 out of 14. That's to get the next green. And then that is then multiplied by chances of getting another green, which is 4 out of 13. Nice and easy. Then we need the chances of getting yellow, yellow, yellow. To get yellow, 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 it's 4 out of 15 plus, or times rather. Now if you get 1 yellow, then 3 yellow you have back. So it's saying times 3 out of 15, then times, to get the final yellow, is 2 out of 15. So now we do this multiplication, and what we're going to get is 5 out of 15 times 4 out of 15, 4 out of 14 times 3 out of 13 plus 6 out of 15 times 5 out of 14 times 3 out of 13 plus 4 out of 15 times 3 out of 15 times 2 out of 13. So I get 29 over 455. So this right here should be 14. 15, it should be 13. We did all of this calculation to get 29 over 455. So this means there's a very slim possibility of you getting all 3 of the same color. Very slim chance. That's that. Nice and easy. Soft. That takes care of the statistics question. All right. Now reach the final part of the question now. And it says, a car is stopped at a traffic light, and when the light turns green, it accelerates to 28 meters per second in 15 seconds. It says the car continues to travel at this speed for another 35 seconds before it has to stop 10 seconds later at another stoplight. So draw the information on the graph. So he didn't label the axis for us, so unfortunately we're gonna have to label it. So no big deal, label our axis. So put on X, Y axis. Now put on X axis. Put the arrow the wrong way. Let's get the arrow in the right direction. And them tell us say go up to 28 meters per second in 15 seconds. Then it travel with a constant speed for 35 seconds. Travel with a constant speed for 35 seconds. And then it has to come to rest in 10 seconds later. That's 15 and 10 is 25, 25 and 35 is 60. So we can break up our time axis. This is time. Can write T for time. Time is in seconds. 60. Can make it maybe 10, 20, 30, 40, 50, 60. All right. So 2 centimeters to represent 10. Then on the Y now, what's the highest speed it goes up to? It tells us that it accelerates up to 28 meters per second. All right, so the Y-axis, I don't know where you want to put 28, but I would want to put 28 somewhere. Let's say this is 5, 10, 15, 20, 25, 30. Let's say this is 5, then 10. I just want to use up all of the graph. 20, right? So if here's 20 and here is 25, then in the middle is 22, and here to here is 1, 2, 3. No, I don't want to use 3. Let me change the scaling. Don't like this scaling. This scaling is not so wonderful. We want our scale to be real nice. We want it to be even. So let's say 10, 1, 2, 3, 4, 20, 1, 2, 3, 4, 30. This is a better scale to use. 30, 20, 10. Let's say this is a scale that we're using. And so now it says that it start. Go again. So go again and look on the question, and it said that the car continues to travel at a particular speed for 35 seconds, and it accelerated up to 28 for the first 15 seconds. So 15, where will 15 be? We know here so will be 20, and so here so will be 15. So at 15 seconds, the car go up to 28 meters per second. Here says 25, here says 27.5, and so right here is 28 meters per second. All right. Then the car travels at this speed for another 35 seconds. So from 15 to 35, that's 50. So the car travels at this speed up to here. All right. And then in the next 10 seconds, it has to stop. So it comes back down to rest. So now I'm just finishing up the graph now. So this is your graph that you have. Mine not so accurate, but make sure yours is nice and easy. Now it says, calculate the distance traveled between the two traffic lights. So the distance traveled is area under the graph. Distance traveled is area under the graph. The area under the graph is going to be the distance traveled. So the area, which is the distance, is going to be equal to, it's a half A plus B. So we need to know A, because the area is the area for trapezium. So A plus B times the height. Now A is this side. The length of this here is from 15 to 50 is 35. So it's a half of 35 plus 60. Half of 35 plus 60. And this is being multiplied by the perpendicular height. And the perpendicular height is 28. So whatever this works out to be is the distance traveled between the two. So put this in our calculator. Put that in the calculator and we're getting a half of 35 plus 60 times 28. That's 1,330 meter. So whoa, in the space of 1 minute, this car going real far. All right. Now the next thing it says, find the average speed of the car over this journey and give an answer in kilometers per hour. So first, let's find the average speed in meter per second. The average speed, I'm calling it V. Average speed is total distance over total time. This is 1,330 meter divided by the total time in seconds, total time which is 60. And so the average speed is being working out to be 1,330 divided by 60. That's 22.17. This works out to be 22.17 is the average speed. .17 meter per second. But we want the average speed in kilometers per hour. So what we need to do is find out how many meter make a kilometer. You could actually convert it from here, you know. You could think of 1,330 as 1.33 kilometers. This is 1.33 kilometers being divided by 60 seconds. You convert 60 seconds to hours. 60 seconds to hours. To convert it to hour, first you convert it to minutes by dividing 60 seconds by 60. This is 1 minute. Then you divide it by 60 again to get, this is really 1 of 60 of an hour. This is really 1 over 60. All right. This is really 1 over 60 in hours. So 1.33 divided by 1 upon 60, that's going to be 1.33 divided by 1 over 60. That's 79.8 kilometers per hour. 79.8 kilometers per 1 hour. Nice and easy, soft. All right, now let's see what else they ask now. The next part of the question now is a particle moves in a straight line such that t seconds after passing a fixed point O, its acceleration is given by 12t minus 17. Given that the speed at O is 10 meters per second, find the values of t for which a particle is stationary. Now a particle is stationary when its velocity is 0. That's when a particle is stationary. A particle is stationary when its velocity is 0. So now, All right. All right, so now we have particle is stationary. Stationary means not moving, and it's not moving when its velocity is 0. Now it gives us A, so we can find the velocity by integrating A. So the velocity is the integral of 12t minus 17. So when we integrate this, what we're going to get is add 1 to the power, divide by the power, that gives us 12t squared over 2, which is just 6t squared, minus 17t. This is the formula for velocity. 6t squared minus 17t plus some constant. We can call that constant k plus k. Now, the next thing we need to know is we need to find this constant k. It tells us given that its speed at the start is 10, we can determine the constant. So that means when t is 0, the speed is 10. So 10 is equal to k. 10 is equal to k. That's what they're telling us, that k is 10. So the velocity is equal to 6t squared minus 17t plus 10. Right? And it says find the values of t that the particle is stationary. The particle is stationary when this is equal to 0. Nice. So that's what we're solving now. So let's solve this. So to factorize this, it's going to become, we're going to factorize it, equals 0. For 6t squared, it says signs are the same, both of them is negative. That looks like 5 and 2. So to get 17, let's see. How can we split the 6t squared? It can be looked up as 3t. Alright, it's taking a long while for me to factorize this, which I really don't like. So I'm just going to go straight to the quadratic formula. When it's taking me so long, I just go to the quadratic formula. So t is equal to minus b, which is 17, plus or minus the square root of b squared minus 4ac. It's plus or minus 17 squared minus 4ac over 2a. Anytime it's taking long to factorize, you can just go straight to the quadratic formula. You'll never go wrong with the quadratic formula. Over 2 times a, which is 2 times 6, which is 12. So the values of t works out to be t is equal to 17 squared minus 4 times 6 times 10 square rooted, that's 7. So 17 plus 7 divided by 12. So I get t equal to, that's one answer. Or another answer is 17 minus, let me see, 17 squared minus 4 times 6 times 10 square rooted, 17 minus 7 divided by 12, or t equal 5 over 6. Those are the two answers. T is either 2 or t is 5 over 6. Nice and easy. T equal 2 or t equal 5 over 6. Nice. It says now, find the distance the particle travels in the 4th second. Now, to find the distance the particle traveled, the distance the particle will travel is distance, let's call it s. It's always the integral of velocity. So we're integrating the velocity from 0 to 4. That will give us the distance it travels in 4 seconds. All right, so it's integral all right, from 0 to 4. So integrating from 0 to 4, that will give us the distance it traveled in 4 seconds, all right? So let's just find S first. Let's just find S of t, right? S of t is going to be equal to the integral of 6t, integral of 6t squared minus 17t plus 10. So this is what we're finding, the integral of 6t squared minus 17t plus 10. When we integrate this, what we're getting is 6t cubed over 3 minus 17t squared over 2 plus 10 plus 10t plus some constant k, all right, plus some constant k, all right. Now this constant k, or this should be 10t, this constant k will be 0. Can I tell you why this is 0? This constant k is 0 because initially at time t, it doesn't cover any distance. So this constant k is 0. And so this is the formula for S. All right, this is S of t. All right, so this is the formula for distance. So the distance it traveled in the 4th second, all right, the distance it traveled in the 4th second. When it said the distance it traveled in the 4th second, that sounds like S of 4. All right, the distance it traveled in the 4th second. So the distance it's going to be, plug in now t as 4, and we're getting 6 times 4 cubed over 3 minus 17 times 4 square over 2 minus 17 times 4 square over 2 plus 10 times 4. Nice and easy. This is S of 4. Nice. So that's 6 times 4 cubed divided by 3 minus 17 times 4 square divided by 2 plus 10 times 4, and that's 32 meters. All right, so that is 32 meters. So that's the distance the particle travels up to 4 seconds. But it says what is the distance it travels in the 4th second. Now this is the distance that the particle travels up to 4 seconds. It wants specifically what's the distance the particle travels in the 4th second. All right, so this is the distance it travels up to 4 seconds, but you want the distance it travels in the 4th second. Now the distance it travels in the 4th second is going to be the distance it traveled up to 4 seconds minus S of 0 minus integral, which is pretty much minus S of 3. So this is the distance it traveled up to 4 seconds. So I want to clarify that. So just to write it down, that 32 meters is the distance it traveled up to 4 seconds, right? Now we need to find S of 3 in order to compute the distance it travels in the 4th second specifically. So we need to find S of 3. So the distance it traveled in the fourth second, so in the fourth second, it's going to be equal to 32 minus S of 3. So we need to find S of 3. S of 3 will be, when you put T as 3, which is 6 times 3 cube over 3 minus 17 times 3 square over 2 plus 10 times 3, which is 7.5. And so it actually travels 32 minus 7.5, which is 32 minus 7.5, which is 24.5 meters. That's what it actually travels in the fourth second. That's it. This takes care of this paper. Nice and easy, soft. Means that 20